Hey everyone, welcome back. We're discussing recursive helper methods and parameters. And our helper methods and parameters are exactly that. They're helpers. They help us keep track of where we are, what we're doing, and sort of where we need to go. Kind of like a bookmark for a book. Instead of starting from the beginning every single time you sit down to read a book, you have a bookmark that will sort of help you keep your place and help remind you where you're heading next. The other main benefit to using something like a helper method is that we want to kind of abstract away from our user as much of the implementation details as we can. So let's go ahead and just pull up an example of what I mean. Now, if I was asking you to write a summation method, int array sum array 1, 2, 3, 4, 5, int sum is equal to sum array, and I didn't give you any restrictions, the sum of the array is, on how you were going to implement it, you probably wouldn't pick recursion by default. You would pick just a normal for loop. So let's write that code. Public static int sum array, int array, int sum is equal to 0 for each number in the, I'm going to do this, for each num in the array, we want to do sum plus equals that number, and then we can just return it. Oops, we need to turn this into an array, save it, and then we can just check to make sure that this works. Awesome, compile worked, and we get our sum of 15. So that worked. There's our normal for loop. Now, if I told you I wanted you to change your function so that it could now calculate the exact same value, but I want you to do it recursively, it's important for us to understand that our calling method right here really shouldn't have to change. The user, air quotes really, but the user shouldn't need to know that now they need to pass in an extra parameter, especially a hard-coded parameter, because we always start at 0. So what is it that we need to do? Well, we can make what's called a bootstrap or a helper method. And this sort of middle manager method is going to kickstart the process of recursion for us. So it looks something like this. We call a method sum array, often named exactly the same or has the word rec for recursive after. And we're going to pass in those two values, the array that came from the user and the bootstrapped or hard-coded value of that index. In fact, really, this should just be a single line. We can just return. We don't even need a sum there. That's fine. And now we can make the actual recursive method, which takes in the array and the index, where we can say something like int sum is equal to 0 if I is still less than the array dot length, sum is going to be equal to the array at I plus our recursive call, array and I plus 1. All right, and then we can just return our summation. Let's confirm that this is going to work. Oh, I better save it. Compiles, no problem, and we still get 15, so we can see it still works. Now, the key here is that we've really separated what we're calling our user and our implementation, right? Our behavior, which is the summing of the array that gets controlled by the main method, and our implementation, which is either iterative, so looping, or recursive, using calls to ourself, are completely separate from each other. We don't rely on the front end or our user, our main method, actually knowing about our implementation. So we employ this middle manager, this helper method, to allow for this really nice, neat separation. In my previous video, I showed you how you could do a reversal of a string, either directly mutating the string, since strings are immutable. We were able to pass in a different sort of string, air quotes, string every single time. But I also showed you how to do it with passing in indices. And now you'd be able to write that helper method in between in order to convert those methods that we wrote that required the helpers, that required that extra index, without having to affect our main method. There are some common pitfalls here too. Since we do have that extra helper parameter, it's pretty common for us to forget to update it. Also, depending on what we're using it for, the starting value matters greatly. So it's really important we're checking for those things when we're setting up our helper methods. Another common pitfall is this idea of mutability. If we're relying on a certain data type or a certain object, we have to remember that while stack frames, when we do recursion, are building up these what are called activation records, these frames onto our stack, they're not actually changing anything in the heap, which means things like mutable objects, their data exists on the heap, and the stack is just keeping track of the reference. This means that it's possible for us to be passing in a pointed value that could affect future recursive calls and layers. We need to be really, really careful when we have mutations to mutable values. So when I pass in my array here, I'm only ever reading from the array. I'm never changing or updating the values in the array. This is relatively safe for us to be doing recursively because there's no chance of me accidentally changing the array in a recursive call that would affect a future or previous recursive call. Now, if instead I was mutating this array, which we will see later on, like in sorts, we have to be really, really careful with how we are mutating it, when we're mutating it, and how that works, so that we don't accidentally mess up our algorithm in a future iteration of our recursion, like in a future call to our recursive method. Now, helper methods really help us understand how to separate what we're going to call our API, right? Our front end, our user, our main, our behavior from its implementation. It keeps our API really nice and clean, keeping it very straightforward and easy to use while obfuscating that implementation sort of behind this thinly veiled wall that is the helper method. It also can help us avoid creating unnecessary copies and keeping our code nice and efficient. In my final video of this topic, I will be actually showing you how to write the merge sort algorithm recursively. So we've already seen merge sort iteratively in a previous video in our last week's topic when we covered searching and sorting. Now this week, we're actually going to take this algorithm one step further and cover it recursively and see how that works. Thanks everyone, and I'll see you in the next video.